everyone, this is my video on my entry for the Thermaltake Seasonal Invitational 2024. This invitational was sponsored by Thermaltake, Seagate for Firecuda 1TB, Palette for 4070 Ti Super Gaming Pro, and ASRock for Z890 Lightning, and Intel for their 265K. I'd like to thank all the sponsors that participated in this event. With that said, I did make 2 videos on my YouTube channel about this build before, but in this video I'm actually going to kind of cover everything from the very beginning, my design idea, what I was trying to achieve in my build process, as well as some of the functional items that I had hoped to achieve with this build. This is actually inspired by pretty much a Porsche 911 GT2 RS. The color that you see in red here is actually OEM matched to Porsche Guard Red. Some of the elements I try to include from the actual vehicles in the 911 lineup, for example, the front grille bars. This is to mimic the area right above the rear spoiler on, for example, like the 911 GT3. I'll put a photo up so you guys can see it. And if I spin it around, and I'll show you guys the rear. On the rear here, you will see 2 exhausts. These exhaust tips are actually very similar to the YSAC package exhaust tips on some of the generations with the insert. That was kind of what I was going for over there. You'll notice that the covers here are satin black, and the inside is gloss. That kind of mimics the car's actual bumper design of a satinish black, and they would have gloss elements inside. I try to bring that as well. I did originally at one point use glossy covers, but I felt that the satin would actually look better when I had to redo them. But with that said, let me go back into what I was saying before about the overall modding design of this build. So for my base design for this case, I decided to make it what I would like to call the motherboard side and the GPU side, with both sides being the same. So what does that entail? That entails essentially taking the case apart and making both sides equal to an extent. So what I've done here on the motherboard side, as you can see, I have a custom motherboard tray on this side holding my motherboard, and I have a custom tray on the other side holding the GPU and the one of the internal monitors. So in CAD, I'm going to be able to show you guys this a lot easier. And all the core componentry, the PSU, the wiring, all the water cooling, kind of sits in the middle between the two. So when I flip it around, you'll see what I mean by the other side. This is the GPU side of the case. Right away, you'll notice that the GPU has been mounted onto its own, I guess, the GPU side of the build. And you'll notice that both sides are essentially the same. And what I mean by that is you can see that I can have the glass on this side and on the other side. So essentially, when the glass is all on, I have dual glass on both sides, rather than the traditional Tower 600 where you have steel on one side. So in order to accomplish that, I've had to recreate the lids so that they're the same on both sides. Well, not same, but it's symmetrical. So both lids had to be recreated, as well as the panels that the lids bolt onto are recreated. So from actually of how much of the case is being used is really just these portions and the rails. So the internal and all the external elements, those are all completely done from scratch. But you can see that I didn't do the 8.8 inch on this side. I used the Thermaltake smaller monitor. Here we have essentially is the Gaming Pro 4070 Ti Super. What I've done is I've taken the 3D files supplied by Palette in their Maker program, and I've brought into Fusion 360 a CAD program in which I designed a complete cover that sits on top of it and inserts over it. So you can see that the GPU is completely surrounded. So it's flush on the top with the RGB, and it's also flush in the front, and there's no overhang or anything like that. So it's actually just a completely new cover that's sitting over the original cover. And above that sits, I believe this is a 12-inch widescreen monitor. This monitor is plugged directly into here, and the reason I have this monitor here is because this build actually, when we talk into the function, I'll actually get into why this is here. Let's see. That pretty much sums up the main portion of the build. Down here, I have the reservoir and the pump This is held on by what I tried to do was kind of like, I don't know how it's going to be hard to see on video because it's kind of dark in that area and it's hard to light up. But if I increase the brightness on my camera a little bit, you can see that this portion here is holding the res, and that all of that is coming into the middle as well. In the CAD, it's going to be a lot easier to see. So aside from that, there's a distro on top here that connects the runs in the radiator, and that brings it into the middle core as well. So that also, I'll show you guys on CAD, is also easier to see. A lot of this, because it's so compact in the middle, it's very hard to show without going into CAD. And then the base, speaking of the base, this is actually an optional add-on for this build. This base does not need to be part of the build for it to run. I can rotate it back in the front again, but before I do that, each side has 3 120mm fans, and essentially this base is originally planned to be in a radiator dock, but I felt that having quick disconnects on this side kind of would have been a little too much. I really didn't see the need of running 2 360s and a 280 for one CPU, so I decided just to make it a kind of an air dock. The way this works is because I have so much glass and I only have that front intake, I wanted to bring more air into the build. So the way this is designed is, once again, I'll show everybody in CAD. It has fans on the inside, and there's middle, there's a cable holder with a vent direction that pushes the air straight up into here. Now, if you're wondering how is it getting into the case, well, on the bottom side here, I actually have another custom panel like on top, and this one has vents that are design matched to the top of this pedestal, so the air flows in 100% freely, unrestricted, and that brings in cool air into the case, which is then exhausted through the sides. So that is an increased intake, and also, I mean, not that you couldn't run this case on the vertical stand, which I'll have some pictures of on its own, but if you wanted something cool to have it stand up on, that is the additional case, not case, but pedestal that's at the bottom. So here's the build in CAD. As I was mentioning earlier, it's easier to show in here. As you can see that essentially both sides are symmetrical in terms of glass on both sides. Obviously, these are not the exact parts inside the case, but you can get an idea. So once I start peeling away here, you will see exactly what I'm talking about in terms of the layout. This piece, as you can tell, is, as I was mentioning, has to be made from scratch. You can kind of see the build breakdown, right? I have my grill thing here, and this is, as I was mentioning, I'll put a photo up what this is essentially from. But you can see here that this plate is completely customized, and I've also added back the original holes to 3D printer area to hold the glass. So it uses the original clasps to hold the glass. Top and bottom are slightly different, even though they look the same. But if I remove this, we can see here more of the internal structure here. You'll see that this is the cover I was talking about for the Gaming Pro. So coming out of the manufacturer tab, if I show everything, this might look kind of messy. So let's just, you know what, let's just show all. All right, we'll just show all components at the same time. Let's show all bodies. Okay, so this is the original cover. These are other parts I ended up not using. This is the actual cover given to us by the palette maker. You can see that it's fairly simple, right? So in order to kind of do something a little more enclosed and unique, I have created this top cover that kind of goes over it. So this is the actual GPU cover, and this is the Gaming Pro in red that you see, and behind that is the actual frame structure that it bolts to, right? These screws go right through all the way to the GPU itself. I found this to be M2 screws, and that is kind of how I'm getting that GPU looking the way it is. On the actual one, this doesn't exist anymore. It's completely just like this, and this also doesn't exist. So what I've done here essentially is taken the palette maker bracket, which is this. I've extended the sides all the way down. I removed, let's see, you can see that. I removed all of this in the middle to make it more flush. I've also closed that gap here that said gaming. I've closed that, and I've kept this window, but I've made it a little bit more. I think I've kept it the same. I think I've managed to keep it the same, so I'm just going to remove this again. All right, so yeah, this has been the same. I've removed that contour here just to make it more flush. So it's more like a completely flush solid cover now than the factory stock cover. And that pretty much handles it for the GPU. This is actually the piece that you saw in the build. This covers the riser cable, so it gives it a clean aesthetic. And if I start removing these, you can see then here that this is the component that holds the GPU. I've drilled holes exactly where it mounts on the back of the GPU cooler, and that is how it's staying in place. You don't see the 16 pin because that's coming through from the inside. And then this one, this side of the bracket is also holding the screen portion here. This arm here is a custom bracket that holds the screen, and that is bolted onto this bracket on the top. While we're here, you can see that there is a distro. This distro brings the radiator from the outside into the inside. It's just a simple kind of channel run, right? If we remove this, I might have to remove a couple layers. You'll see that here's the inside. All right. Obviously, I'm not using a Susloki and stuff, but these are parts that were pre-catted, and I just saved a lot of time from redrawing. But you can see this is the inside core, right? So all the water cooling, everything, and the powers and the cables and everything sits in the middle. If I remove the motherboard, let's see if I one click off the motherboard away, you'll see that this is the motherboard side, right? And then the motherboard side, this also has been modified at the end. I ended up cutting this open over here, so in order I can actually access the cables. Otherwise, it's going to be impossible to put together. But obviously, the water cooling feeds into here. And on the bottom, you can see that this is the reservoir holder. This wasn't originally supposed to be hydro dipped, but I decided to kind of go for that dark chrome look, which is what I have on the rear, these rear exhaust pipes. You can see that the design here is actually with the LED ring on the inside, is what you saw. The way this is done is this is a 3D printed layer on top. Like I said, this matches the Weissach kind of exhaust pattern on the older models. If I remove that, you'll see that there's the diffusion plate, and behind that is the LED ring, and that is bolted onto this thing here. From here, this is actually an extension going into the power supply. If I remove that, you can see that this is the... It's a lot to remove. Let's see if it showed. Okay. There's a plate here in between that has wiring pass through to allow the wires for this LED to pass through, as well as the power switch on the very top to pass through. So that pretty much breaks down how the build is constructed. You can see it's pretty bare now. It's kind of easy to see how everything's put together. Obviously, it's a lot more of a easier said than done. But moving on, I'll break on to the stand. So before I move the stand, quickly let's go over the motherboard piece. This is the motherboard armor, one of the many things. This originally was supposed to be a two-piece. It ended up not being a two-piece. Originally there was supposed to be a cover that hides the riser, like shown here. But because I kind of like the way the riser looked, I ended up not going with that. But that is the motherboard armor. Let's see what else. Yes, so moving on to the stand. This stand here is actually a couple pieces. This is the venting I was talking about. On the actual bottom of the case itself, I do have a matching vent glass, which I'll actually show you right here. Oh, this is the actual bottom of the case. Well, when it sits in the dock, this is the bottom, or even when it lays on its side, this is the bottom. These holes, as you can see here, coordinate perfectly with the holes on the stand. So it's this row in the middle. So when it lays on top of it, it pretty much passes air through directly. The way this is working is if I remove this top layer here, there's another aluminum layer underneath to give it strength. And once I remove that, you see that in the middle there's a channel here. This channel actually deflects the air directly straight up. It is a 42-degree angle. I found that actually to work the best, and it also holds the wiring for the fans in between. So that's how that works. Now, in terms of the diffusion effect, I did cut a piece of acrylic on the side that's not fully clear, but well, I guess what they call is there's a certain model number for it, but I forget. But that is a layer that's over here, and behind that obviously is aluminum structure. All of this is a solid aluminum. All the red you see. but that kind of gives it the strength to hold up the build itself. So that's the stand. So there's a lot of talk about AI, especially even last Computex, and a lot of technology companies like to talk about AI PC. Even if you buy an Intel CPU, it says AI inside. That really comes from some of the architectural things like MPU for acceleration for AI tasks. But NVIDIA cards, which are well known for AI use, are also very good at that. So to fully leverage the capability of this machine, I've decided to have it run AI models locally for multiple reasons. The first reason is being that, number one, you're not using cloud to get those results. So for example, here I have OpenWebUI, which you can see is running in a Docker. For those of you that don't know Docker, Docker is a container system. It's kind of like a virtual machine without all the bloatware. Okay, so I have WSL running on this machine here, hosting Docker and also hosting Wyoming Whisper, which is something I'll go into later. So here we have OpenWebUI, which is running locally, and I have a few models here. Some of them are faster, some of them are going to be a little slower. But given this is a 4070 Ti Super, there's only so large of a model I can load into VRAM. So just to make sure you guys that this is 100% running locally, you'll see that it's localhost. All right, I'll do a screen capture. It's probably easier to see than this. But I didn't want people to think that I was kidding you when I was saying this. I'm running this locally. So if we go to performance, you can see my GPU usage is 0, right? And if I were to come here, and I just wrote, tell me about NVIDIA. So using Google's Gemma model, it's going to start. And you'll see that my GPU usage has skyrocketed 97%. And it's telling me about the Gemma's latest model. Sorry, talking about NVIDIA, gives me some stuff and gives me context. Now you're asking, why would you want this running locally? Well, there's many things you could do with running locally. For example, if I go to, I can ask it to generate an image. I can ask it to search from things on the web. If I want to scour the web for certain things, but also it allows things like upload files. Here you can put, for example, an array of documents. You can give it access to your network shares, and you can have it find things, sort things, do all sorts of stuff. A lot of this stuff can be then coded to do other things. So this example here, I am uploading an image of the Thermaltake Tower 600 from the website, and then I'm asking it directly questions about this case. You'll notice that it picks up all the product information and can then deduce answers such as how many fans does this case support? So another reason to run AI models locally is that you can use it as an assistant. You'll see here now that what I'm going to say is going to be transcribed into text on that screen here, and then it's going to run the AI model and fetch me a response. So for example, TTMod, tell me about Computex. So you'll see that is now been converted into text. My GPU is going to spike because it's running that locally, and then it's going to feed me a response.
Computex is a large international computer and technology trade show that takes place
kind of like
annually
when
in
you ask
Taipei,
Google or Siri,
Taiwan.
Right?
It features the latest products
But this is
and
going to go on a little
innovations in
bit.
computing, including PC hardware, components, peripherals,
So, well, that's
software,
continuing to go. Additionally, what we can talk about is device control. So, for example, if I were to zoom out here a little bit, example device control, I have 2 light bars on the table here, and we're going to ask the computer to turn it off. TTMod, turn off the light bars.
All light bars in the PC room have been turned off.
So we can also do other things, like there's a lot of integrations. TTMod, it's a little bit picky. TTMod, tell me about the garage.
The garage is currently off. The X5X Drive 40i lids and X5X Drive 40i windows are currently in the closed position, and the door lock state is also off. The climate control is turned off.
So I could ask it to start it, but I'm not going to do that, obviously. But this gives you an idea of kind of the assistant functionality along with having AI on board. So with that said, thanks for watching. This kind of just wraps up this whole thing. Obviously, I wanted to take this a little bit further, but given time constraints on my own end, I could not take this as far as I wanted it to go. But with that said, thanks for watching. If you like this build, feel free to vote for it. All right, thank you.